All right, folks, a very warm welcome to this 2-day mini course on AI agents. The course is divided into 2 days. The first day is theory. The second day, you build something. But as a teaser, what we will do is in a few minutes, you will actually see what you will build. Actually, we build it for you, but we walk you through the solution. That code people have found very useful. We call it metamorphosis for reasons that you will figure out. And you're free to use that. So, in terms of the licensing, it's a fair bit of code. You're most welcome to take it, use it in any way you want for your hobby projects or in your corporate environment. So people ask, can I use this part of the code in my workplace, that part of the code? The simple answer is yes, you can do whatever you want, except for one thing. Can you guess what you can't do with that code? Yeah, please don't sue me for that. Don't sue Support Vectors. We are a small organization, research and training organization. Don't sue us. Right? So have mercy on that front. Other than that, do whatever you want with that code base. And people do whatever they want with the code base. So as I said, today is mostly theory and motivation. And I'll start very simply. For those of you who are already familiar with agents, it might come across as a bit too high level of fluffy talk. Bear with me, because in the audience are people who come from quite different backgrounds, and they have let me know that they would want me to motivate it gently. So we will motivate it gently. Along the way, we'll see a demo of a product. Tomorrow, we'll walk through the code of the product. Does that seem like a good approach? So you can tomorrow when you do come, you're welcome to bring your laptops. Even if you don't bring, of course, we'll walk you through the code and we'll go through that. This is so again, this talk is an introduction to concepts and getting started code. Right? Now, when we this is a little bit about me. Uh, I hope I still look as young as this picture. Right? So typical. I come from India, from the usual um, BTech from IIT, then US for doctoral studies and so forth. You can look up my LinkedIn if you wish. Uh, this again, I will skip. We like the team at Support Vectors is well achieved. We have dozens of platforms, machine learning platforms. We have built research papers and patterns. Let's skip all of that. Oh yeah, our alumni do very well. 3,500 alumni. So we do have a good. So anyway, forget that. Okay, let's go to this. What is a today, from a very practical perspective, when people talk about agents, it's hard to find an organization that doesn't claim to be doing AI agents or doesn't aspire to do AI agents. Is there any company that has never talked about AI agents or getting into AI agents? No one, right? How many of you are actively doing AI agents? Or you know of your colleagues doing AI agents? How many of you know that your a company wants to get into AI agents? Lots of you, right? So this is it. So why do they want to do that? See, the agentic systems has been an aspiration within um, enterprises for decades, ever since machine learning began to show promise. The, the first thing they wanted were agentic systems. So we will dissect what it all means. But I would like to just step back and ask, today we talk a lot about AI. AI in popular imagination, in the imagination of taxi drivers and school children and teachers and nurses and physicians and accountants and hikers. It sort of burst upon the scene with the coming of ChatGPT. That was a moment. ChatGPT had an adoption curve that is unprecedented. Within a week, there were, I think, tens or hundreds of millions of users within a month. Right? Now, the penetration of these chatbots is far and deep. All people in any way associated with the STEM field certainly are using it more or less on a daily basis, if not on an hourly basis. If you look at what these systems are, and you look at Google search, for example, which has also become infused with generative AI, right? Everything is getting infused with generative AI. Even your humble programming ID, Visual Studio Code or PyCharm or whatever it is that you were using, IntelliJ, now are agents. They are all AI agents. The three core topics that gets involved whenever you talk about generative AI broadly, enterprise AI technology stack. Almost everyone is involved with at least one of these three. You're doing AI agents, you're doing retrieval augmented generation, that is, you have a vast amount of documentation, and now you want to talk to those documentations. You want those documents to answer your question. Almost every company had enterprise search of some kind. It is logical, intuitive to ask the next question. Why do I have to search and then read those documents? Why can't the generative AI read the documents for me, the search results, and answer my question? To do so is RAG, retrieval augmented generation. The third thing that you realize is the power comes not from just making API calls to a remote frontier model or downloading a model from Hugging Face or wherever, Olama. Power in to create effective AI systems, the power oftentimes comes from taking those models and owning them, adapting them to your domain. So, domain adaptation, task specificity, they amplify the effectiveness of the AI models. That to do those things is fine tuning. It's almost like, as you know, when you and I buy a car at our age, we just drive it. But when a teenager buys a car, what is the first thing they do? Open the hood and start fine tuning it, right? Because the default configurations are horrendous according to them. You have to extract the maximum potential and you start fine tuning the car. The same analogy works. To fine tune the model is really to extract its, harness its power, but not just to harness its power, to change its character and to amplify or induce new skills into the model, completely new skills which your domain, your task needs. That is the frontier. So these are the three core activities that go on in this. Now, I will take an unusual approach to AI agents and give you a little bit of a historical perspective, and I'll try to keep it brief because it might, to some of the techie heads, it might look fluffy, but I tend to do that. Consider it my idiosyncratic approach. But I will argue that what you think of AI agents is not something that um, sort of burst upon the scene in 2023, 2024, 2025, but dates back a very, very long time. AI agents is the realization of a millennial human aspiration. And I'll talk a little bit about it, but I'll try to keep it brief. See, there's an old story, if you look across civilizations. In the Chinese civilization, there was this beautiful story of an engineer, Yan Shi, who built an automaton and presented it to the king, the Mu of Zhou. I hope I'm pronouncing those Chinese names approximately correctly. Uh, it walked, it sang, it flirted. And then the king was worried that isn't it just a person dressed up and claiming to be a machine, an engineering creation? And the engineer asked it to open the chest and see the machinery. And it did that, which made the king exclaim, can human skills match that of nature? That is the question that resonates today. We are asking this question in a different garb. Can the intelligences, the artificial intelligences we create, can it match that of nature? In fact, the answer to that seems to be resoundingly yes. In many, many areas of work, these machines outdo any of the nature's creations. Specifically, they outdo humans by orders of magnitude. Right? There's an interesting paradox that that which humans find easy, machine intelligences find hard. That which machine intelligences find easy is extraordinarily hard for us. They find it a piece of cake to ace SAT, GRE, Math Olympiad, everything. We find those things extraordinarily hard. But if you were to ask a machine intelligence to stir a, some drops of juice into this glass of water, they actually find it hard so far. Right? And that's the a fundamental asymmetry we live with. We live in a world in which machine intelligence is a different kind of intelligence to human intelligence. And the strengths and weaknesses of these intelligences are very well delineated. And therefore, for every task that we do, and that's a value proposition of agents, every task you do, the right question to ask is, which kind of intelligence is optimized for this task? Which kind of intelligence would you want to bring? If it is a cognitive task, if it is a reasoning task, more and more we are finding that machine intelligence is the superior tool. If it is a tactile task, quite often humans are the superior tool. Right? And so it goes. Now, many of you would remember the story of Aladdin and the magic lamp, right? The story is a genie comes out of the lamp when Aladdin rubs the lamp, this boy, and the genie can do anything you want. He says, build me a castle. And sure enough, genie comes back after a while and says, there's a castle ready for you. The reason I bring this is because from a technical perspective, it captures the heart of AI agents. See what happened. Genie didn't say, okay, give me line by line instruction. Where should I go get the bricks? How much should I pick the bricklayer? Right? And then first, should I get the brick or the sand? What should the palace look like? Right? Where should I dig and start building the palace? It does not ask that. Aladdin doesn't tell the genie any of these things. What does Aladdin give to the genie? Gives a goal. Can you please build me a palace? Isn't it, guys? The genie has to, with a goal, the genie parses that goal. One would imagine, figures out a plan of how to make the castle come about, right? A palace come about. It reasons, it thinks, it acts. A palace wouldn't just come through a pure act of thinking. You have to have tactile impact, physical impact on the real world, because a palace is a physical thing. Right? In other words, genie observes, plans, reasons, and acts upon the environment, mutates the environment. Slowly, step by step, the environment reshapes so that before in the environment there was no palace. Afterward, after at the end of the agentic process, there is a palace, right? That is a palace. In the beginning, you had a goal. In the end, you have a realization of the goal, or what the genie considers a fulfillment of the goal. And that is the heart of agentic systems. You do not program agents. You create systems that work with goals and their capacity to reason, to act upon the environment. And that is the foundational paradigm shift that programmers have a hard time getting used to. We as programmers, are inherently conditioned to think in terms of spoon feeding instructions. To spoon feed instructions is called programming. Are we clear, guys? And now we say we need a point of departure. We need to unlearn those habits and learn how to set goals, achievable goals, and empower the agents with the necessary tools. That is one shift I find is underappreciated by people when they either teach agents or they learn agents or the textbooks. It's a fundamental shift. And I have often felt that one should start with that shift, that mindset, that when you build agentic systems, articulate goals clearly and give enough information for the agent to plan, act, reason. Another similar mythology comes from the Hebrew tradition. Forgive me for walking all over the world, this map. The Hebrew tradition had the concept of golem, which meant that some rabbi of great wisdom could make a clay person and then infuse it with life, and then it would be powerful and do whatever you asked it to do. Except that came attendant risk. If you were not careful, it could do a lot of damage. That speaks to both the technical harm that agentic systems can do. In a recent incident, one company had an agentic system which had which was doing taking user instructions, doing text to SQL, executing the SQL, acting upon the real world, a database, and it so happened that it managed to delete the entire database underlying the enterprise app. It actually happened. That is the technical risk that agentic systems come with. Right? More practically, people keep talking about agentic systems and whether we can trust what they do. It's a daily concern. And so you can see that what used to be a more metaphysical sense of risk from the golem translates into very real concerns at the technical level today. The last one is my favorite, and I promise you, it's the last world tour example I'm taking from different cultures. In the African archetype of agency, and it brings out another aspect of it. There is a concept of a god in African tradition of Yoruba Ifa. He sends emissaries, and I suppose this is a rendering of an emissary, to earth, to a village, to a community, to improve the life of humans, to help them out. But with only a goal, not do this and tomorrow morning do that. Each emissary takes its goal, a different goal, goes and mixes up with the human population, the community, and subtly, unknown to the human community, they are creating positive effects. So, this is the story of Urumila's emissaries acting in the human world. And one of the statements they make, which from an agentic perspective actually has a huge resonance, it says, wisdom is too vast for one alone. In other words, in very practical terms, in today's agentic system, the whole point, the way this came out, the theory of agents came out, I can't help remarking at this statement because when the academics, the researchers, more than 3 decades ago, started thinking of agents, AI agents, the word they used to use is distributed intelligence. It is the theory of distributed intelligence. Why distributed intelligence? It's very simple. Let us say you want to build a hospital. Do you go around searching for that versatile Leonardo da Vinci who knows the civil engineering of buildings, who knows how to negotiate materials from the vendors, from the providers, supply chain, logistics, who knows electrical engineering, who knows how to uh, properly populate an operating theater with the right instruments, the pharmacy with the right medicines, who can play doctor, then physician, then play the surgeon, and then play the nurse. Perhaps in a population of 7.5 billion human beings, there might be one human being who might be competent at all of this, or two, but certainly not a genius at all of them. But what you can find are absolutely remarkable civil engineers, absolutely remarkable procurement officers, and supply chain logistic experts. You can find remarkable nurses, you can find remarkable surgeons, remarkable physicians as diagnosticians, remarkable electricians, isn't it? The world has one trick ponies. We all specialize, and therefore that was the crux, that Learning from that, if we do a complex task, does it not make sense to have distributed piece of intelligence, each excelling in its own domain? Right? That is the heart of agentic systems. Agentic systems is not automated workflows or whatever it is that you have heard. The whole foundation of agentic systems came from distributed AI, and it came from the fact that if you take, it is far easier, even in the world of machine intelligences, to create pieces of intelligence that excel at one thing, right? Specialization, and then have a division of labor in solving complex tasks, very much as happens in the physical world with biological intelligences. That was that was and remains the foundational concept of AI agents. And therefore, I love this statement from the African tradition, which says, wisdom too vast for one alone. Doesn't it seem obvious? The value proposition of agents when you think of it like this. And the exact phrase, oh, I don't know why Steve Jobs' name is there. I take it back. It has nothing to do with Steve Jobs. The slide error. Wisdom is like a baobab tree. No one individual can embrace it. I hope you all agree. Right? Knowledge and learning has become so vast. You and I are one trick ponies. Some of us are two trick ponies. Some rare ones are three trick ponies, but it ends there. Right? So, what is the resonance to multi-agent systems? The agentic systems that we talk about today, what are the resonances? One thing that I want to emphasize, let me go back and say, when the god Urmila sends emissaries to people, what are the emissaries getting? They get a goal, but they get something else. They get autonomy to figure out how to fulfill that goal. Right? So associated with it is the word in English language called agency. See, think of it like that. Sometimes you get a boss in your workplace who gives you micro instruction. And before you have had so much as time to get back to your desk and start doing your work, he's again overlooking and giving corrective actions, corrective comments. How many of you absolutely love such a boss? Raise your hand. Not one of you? Why not? What did the manager not give you? Freedom to reason, think, agency. Right? When, for example, was common 100 years ago, women had no freedom. For everything, they had to take permission and instruction from men. And no matter what they said, a man would mansplain what they said. It still happens today to different degrees, lesser degrees, but it is far more widespread than we agree or we acknowledge. What do women resent? They are missing agency, autonomy, agency, the expression of their own intelligence, isn't it? And ability to express it through action. That is agency. So the word agent comes from agency. Agency implies autonomous actions that it can take on its own. Reason, think, and act. Are we together, guys? That is the heart. If you say, when we say agents, why the word agents? It comes from agency. Implicit is the core idea of autonomous reasoning and action within its sphere of activity, within its little mandate or goal. Right? So please do remember that. And so you see that in this story, which is one reason I like it so much, this tradition. You consider, when I look back at it and look at parallels between which mythology in the world best reflects all the core ideas of agentic systems today, I found that this one, I couldn't find a better one than this. It's so key takeaways. Autonomous behavior fascinates across centuries. Autonomy, automaton is an early archetype, technology. And the last point that I want to make is See, it is millennial aspirations that bear fruit one day in technology and become powerful technologies that transform our life. If you really think about the agentic system, today we live in the world of agentic systems. When you chat with ChatGPT or Claude or Gemini or DeepSeek or whatever, you may not realize that they are agentic systems. You ask it a question or perplexity, what do? They either know the answer or they plan how to answer your question. They make some steps, go search the web, right? Occasionally run code, generate an image, right? And at the end of it, they come back with a result. Whether you know it or not, when you prompt these systems today, you are giving it a goal, right? And sometimes they take a long time to fulfill your goal. I remember once I gave it unwittingly to ChatGPT a goal, and it took it took 24 hours or 26 hours, I think, to finally come back with the answer. Was it sitting idle? No. It was busy doing things. And at each stage, it told me how much it had accomplished. 26 hours later, it had the answer. And the answer, the power of the agentic systems is I could have spent, honestly, $1 million and I might not have gotten such a good detailed answer because it needed interdisciplinary depth, the coming together of many disciplines to answer the questions, the goals that I had set. And that is the power of agentic systems. Everywhere, whatever you see, your search, Google search has become an agent. Perplexity is an agent. All your chatbots are agents. Wherever you look, people are, all the powerful applications that you see are almost all of them agentic RAG systems in different garbs. Your coding agent, how many of you use Cursor or Windsurf or Cloud Code and so forth? What are they? Coding agents. How many of you feel that they are beginning to code alarmingly well? Raise your hand. We all are. That again is the power of agents. So, what really are agents? Again, the last of my high level points. You always hear the story of the blind man and the elephant. Each blind man touches a different part of the elephant and has a completely different version of what an agent is. Right? So, ask 5 people what an agent is. I bet you will get 5 answers. Actually, ask 5 experts, then you'll definitely get 5 answers. If you ask 5 laymen, they might give you more or less the same answer, but all 5 experts will disagree. So you ask people who used to aggregate APIs, right? You remember the Zapiers and so on and so forth. Lots of people, or and so forth. Or for example, Salesforce had a rich internal API within their platform. To them, agents are just automated workflows. How many of you have heard that statement? Agents are mostly like, there's a very close parallel between agents and automated workflows. That's what they are. It's a perspective with a grain of truth to it, but it is a part of the elephant. You're touching only one aspect of the elephant. If you ask the programmers, they are suspicious of this whole hoopla about AI agents. They will tell you that agents are just microservices and functions fashionably dressed. Have you heard people having that suspicion? Right? Some of you have. Then, oh, if you ask Richard Sutton, one of the great pioneers of reinforcement learning, which is directly uh, foundational to agents, what do you think is an agent? It says they are learning entities in environments. Right? Then there's also divergent definitions even within the academia. One definition of agents, so I'm giving you this perspective that the theory of agents is actually decades old, at least 3 decades old. One of them one perspective is these are reactive systems. It says that systems that perceive the environment and act upon it. So they focus on the input and the output, the sensors and the actuation. But according to that definition, your thermostat is an agent, isn't it? And they're pretty comfortable with that point of view. Then there are other people who think that these are embodied intelligence perspective. It says that when you give a physical form to an agent, intelligence emerges consequently. Think of a self-driven car. An algorithm sitting there on your computer doesn't manifest the intelligence of driving self-navigation on the road. That is realized only when you put it in a physical car and it controls physical things, your steering wheel, your brake, your acceleration, isn't it? And the self-driving is the embodiment of that intelligence. Would we agree? So that's a perspective on AI agents. Then the other is multi-agent systems. It emphasizes more the collective, the coming together and coordination, or the distributed systems view. As you must have surmised, I am closest to this point of view, the perspective of distributed intelligence. Nevertheless, all of these perspectives are correct. They are touching a part of the elephant. There is also a tools maximalist perspective, which is of great importance actually these days. And not many people realize that most of the agentic systems they build should actually have been re-architected properly using the tool maximalist perspective. I always advocate, and this is for the enterprise bootcamp that we do, that start with the tools maximalist perspective and then depart from it as needed. What does the tools maximalist perspective say? It says that the power of agent is just a coordinator who says which tool to pick up now, right? And do its work. That piece of intelligence which can create a coordinated action of tools is the agent, right? And therefore the intelligence emerges. That's a perspective. And you can see that if you take this perspective, and Anthropic took that quite strongly, this perspective quite seriously, a foundational protocol called the Model Context Protocol, we'll talk about it in a moment, literally came from Anthropic. And you can see in their blogs, etc., a subtext that says, hey guys, a tools maximalist perspective is a good way to start or get your work done for most situations. Then, as I said, the origins of distributed AI goes back decades. I deliberately put the picture of a steam engine because I love railways. My father worked in railways. And I looked up to make sure that yes, when distributed AI theory was being concocted in research communities, the steam engines were still thundering down railway tracks, at least in India. Right? It goes that far back. So, what is the foundational loop of an agent? It is to observe an environment, to plan, reason, act upon the environment. So the environment changes in a way that makes it, in small ways, closer to the goal. In some significant way, small but significant way, takes it closer to the goal. And then you iterate. You keep repeating the process. Are we together, guys? That is the foundational idea of it. So here's an example of good agentic behavior. We'll say that agent is an autonomous observer. Again, autonomy is there, reasoner, an actor in an environment. It sort of sums it. One agent, but not an agentic system. Agentic system is the coordinated action of many agents. Right? But an agent is this. So if you give the agent a question, is it a good time to visit Maui? Now think from the environment, observation, reasoning, planning, reasoning, and action perspective. What is the observation? What is the environment? Imagine a scratch pad in which now the question has appeared. Is it a good time to visit Moi? The agent will observe the text showing up, isn't it, in the environment? Will come up with a plan, will reason and come up with a plan. It will reason and say, oh, for that I need to know the weather, I need to know the flight and the hotel costs. By the way, I again mistyped flight and flight costs. Flight and hotel costs. Those three things seem primarily essential. Would you agree, guys? Right? And it might even further argue to itself that let me make a checklist of these items, but I should start with weather. But the moment you talk of weather, one man's good weather is another man's unacceptable weather. I once lived in upstate New York, and here is an incident that actually happened to me. A researcher who came from Eskimo roots, lived in Alaska, he refused to visit us in that Syracuse area, apparently, in early March. Now, in early March, if you live in upstate New York, you realize that snow is all the way there till April. But in March, he refused to come down. Why? Oh, what if the snow melts? He felt comfortable in a world in which there was always snow on the ground. Right? He didn't feel comfortable with thaw. It's a cultural shift for me, an awakening that it can happen. You and I, would you prefer completely thawed ground and snow everywhere, or would you prefer California weather? Right? We have different roots. So now that brings up contextuality. The moment you talk of weather now, the agent has to know what is good weather for you. So it has to dip into its memory to figure out what do you mean by good weather, because good weather, one man's good weather is another man's bad weather. Would you agree, guys? One man's affordable flight is another man's too expensive flight. People have different budgets, hotel prices, etc. Acceptability. One may insist only on traveling premium class, business class or above. Another looks for the most economical ticket for the vacation. Right? So you need to contextualize that. That is all part of reasoning and planning. Isn't that what happens when you go to your familiar travel agent and says, hey, I feel like going to Maui. Is that a good idea? A travel agent who knows you always answers it contextually, isn't it, guys? That is the reasoning part of it. Then to know the weather, what will it do? It will use tools, the weather API, whatever necessary, right? And then what will it do? Observe, reason, act. Call the weather API. What will happen as a result of invoking the weather API? Some response will come. That response is now part of the environment. Your scratchpad as the user, your task list was there. In the scratchpad, you wrote a task list. Have you noticed your cursor and other things creating task lists? It creates a weather. Now, weather responses come. It's also part of the environment. Agent observes that, may conclude that it's too hot for you, right? In Maui at the moment. And therefore, it may say that, okay, time to short circuit. Tell the user it's really bad weather. Don't go now. Maybe there is a hurricane coming, right? So that ends the chapter. But if it determines that the weather is conducive to you, it may note down the weather is conducive. So one gate is passed. Then it may reason, what do I do next? In the checklist, look at flight cost. Once again, it will invoke the flight API, get back flight costs, reason over the responses, pick a few good ones if they are within your budget. Now it says, okay, this part is done. What would be the next part? Likewise, it would move on to the hotel cost search. So the environment is, as it keeps writing all these findings in the scratch pad, do you notice that it is using memory? It is using a scratch pad to make progress. That's one of the underappreciated parts of agentic systems. You should always build memory and scratch pads into your agentic systems. Now, once it has done all of that and convinced that yes, it's a good time to go to Moi, it is within the user's budget. Hotels are reasonably priced. The hotels that you like to stay in, the flights are reasonably priced. Then what does it do? The final act is to act upon the environment with what? A well articulated response. It doesn't show its homework, right? Scratchpad. It instead comes up with the response and it articulates the response. Guys, are we making sense? That is agentic system. Right? It creates a recommendation. So again, I want to reiterate this thing. Agents implies agency. There is no agency without the ability to autonomously reason and act. We realize that don't try to program agents. That's the antithesis of agency. Right? Agents reason and act. The word react is very popular in the AI agents literature, though I would say that it misses the observe part. Remember, observe, reason, and act, or more particularly, observe, reason, plan, and act. Plan is underappreciated. In fact, most good agentic systems focus overwhelmingly on good planning ability. So, key takeaways: autonomy means more than functions and microservices. Would you agree? Why is a microservice not an agent or an agentic system? Because it lacks autonomy, it lacks agency. Right? Reasoning connects observations to actions towards a goal. Tools empower both observations and actions. You need tools, right? Would the agent be able to answer the question if it did not have access to weather tools, flight cost tools, hotel cost tools? It wouldn't be able to properly answer that. So why AI agents is again the last of, I guess I shouldn't say. We go a little bit deeper into it. See, agentic patterns actually work. There is accumulating evidence that a constellation of small language models, people use the word small LLMs, though that's an oxymoron. How can you have a small large language model? Right? But nevertheless, the term has stuck. You can use small LLMs, and when you do a distributed intelligence from them with careful planning, reasoning, action, overwhelming evidence has accumulated that they outdo frontier class models with one shot prompt. In fact, now frontier class models, like by frontier class models, I mean through API call. Because if you go to ChatGPT, you are using a frontier class model. But guess what? You're not just using the frontier class model. What are you really using? An AI agent, right? So then the game changes completely because now everybody has realized that there's power in the agents. Right? It is more aligned to human team and problem solving. Guys, why do we form teams? Because we want division of labor, we want specialization. Organizations excel at finding your key strength and aligning you to a task at which they can most harness your talents, isn't it? That's that. And there's no going back. Once you get accustomed to solving complex tasks, there's no going back. How many of you are willing to give up cloud code, cursor, windsurf, anti-gravity, and say, let me pull out an ID in which all of these are missing. Let me start coding go back to coding purely in VI. Raise your hand. No VI enthusiasts left behind or left remaining? Right? See, they were there. If you remember, almost till the AI agents came, many of us, I count myself amongst them, I used to actually edit in Emacs. I'm in the anti-camp of VI. I'm a Emacs camper. I would code in Emacs, but I had an IDE open for debugging purposes, right? And for a global view of the code. But I still prefer the shortcuts of the Emacs. I was a Emacs diehard. Today, why do I not use Emacs? I instead make Emacs bindings into the cursor to get salvage as much of the Emacs power as I can, but stay within that ID. Why do I do that? Because all the AI power of auto suggestion, an agent observing what am I typing? What does this user really want? And then suggesting completions, you would lose otherwise, right? So we none of us are willing to go back to a world before the dawn of agents in practical life. It is now a reality. So, what are the key agentic patterns? And this is the rubric I always use. I say that if you're building an agentic system, this is your checklist, this is your rubric. Make sure it has that. Planning, planning, planning. How many of you have noticed that when you use any of the frontier models in deep thought mode, it goes into a thinking planning journey and it even creates checklists and then puts tick marks against the checklist. If you use a programming agent like Cursor, Cloud Code, Gemini, Codex, you literally see it happen on the scratch pad. How many of you have observed that? It starts by planning, reasoning, and then planning. Task decomposition. That planning leads to what? Checklist of tasks. Task decomposition, sorry. Coordination. If there are multi-agents there, they start coordinating with each other how to do the thing, right? And you'll see that in action in a little bit. Collaboration between the agents, critique and reflection. One power agents have over one shot just giving a prompt to a frontier model and hoping that the final answer pops out is that because it's a multi-step journey and iterative, whatever answer comes out, you can always reflect upon it and see if it is correct. Here's a little secret, guys. How many of you know this trick? Let's see. You give a you ask a question to an LLM. Pick your LLM, whatever it is. Don't even bother reading the answer. Just say, "Hmm, put more effort and do better." Or just say, do better, blindly. See what happens. Or just ask it, reflect upon your answer. I think you can do better. Do this experiment. You'll be very pleasantly surprised. One of the, I suppose, baseline prompting tricks is never to take the first answer. Right? Ask it, what have you missed? So I have a prompt that keeps on asking this thing, do better. After that, then I ask, what have you missed? Right? And then by the time I get to the third answer, I'm willing to keep it. Right? If nothing else, three calls to get the same answer, it may still say, no, I think I covered everything, but no harm done. You'll be surprised how very often the answer improves. Right? That is critique and reflection. In an agentic loop, that becomes obvious. One trick that I say is, if you have for example, um, let's say a writer who will take some facts and then write it as a paragraph for let's say a newsletter, there should be a senior writer whose only job is to critique it, find ways to improve it, and send it back to the writer. So I always create roles in pairs. There's always the doer, and there's always the critique, the senior of that. Right? I suppose that's why you all have managers. Right? How many of you feel that your manager is always telling you, giving you compliment sandwiches, saying, "Oh yeah, great job, you did well. Oh, by the way," and then, "Okay, overall great effort." Raise your hand. Right? Are you all managers to compliment? But at the end of it, while you all know it's a game, how many of you agree that it does lead to better products, better outcomes? Right? So what in real life or corporate life shows up as compliment sandwiches actually gets reified in agentic systems as a critique and reflection, right? So now my team is also on the call, and I wonder if they're thinking, oh, that's what ASIF does. So memory, do I need to speak more? We talked about the use case of user asking, should I go to Maui for vacation? Right? Memory is crucial. If you're using coding agents, you see it. You literally see the memory, the scratch pad, the thinking going on. Right? You need that. Tools, of course, hardly needs to be told. And so tools and these things are redundant. Sensors are also tools. So this is your final rubric, guys. If you build an agentic system, ask yourself, do we have these foundational elements in the agentic system? Does it resonate with somebody who is doing agents on a daily basis? I hope it does. So you get empowerment from tools. I will talk about it a little bit later. Prompt engineering brings role and goal clarity. Once again, we'll dig a little bit deeper into it. And orchestration and collaboration, there are frameworks that help you do that. Specialization, agents is all about distributed intelligence, because then each piece of intelligence you can fine tune to for domain adaptation and task specificity, isn't it? Does that make sense, guys? You can fine tune it for that purpose, just like we do in human societies. And so then comes the last pillar of agentic systems, not agents, but multi-agent agentic systems, which is the collaboration part. There's a old saying that I think a Yankee coach said it, that it's extraordinarily easy to gather brilliant people, talented people, extraordinarily hard to make them work together as a team. How many of you have experienced that? Trouble with very talented people is they are like better fish. You can't put two of them in a tank, quite often. So that's also in the agentic world, the multi-agent collaboration matters quite a bit. So we'll talk a little bit. And the other problem with the reason that multi-agent uh, orchestration you improve through reinforcement learning, MARL is expensive or hard because of a problem called non-stationarity. I told you that an agent observes the environment, reasons over it, and then acts. So imagine 6 Roombas in a room. They observe that there is a dirty spot. What will be the logical reasoning? Let me go and pick up that dirt. But while it is reasoning, the other Roombas might have thought the same thing. And so by the time it acts, the underlying environment has changed, isn't it? Now in its collision path is are other Roombas. That is the problem of non-stationarity. Means the environment is not stationary while you're reasoning, right? And so your action, by the time your action comes out, it becomes suboptimal for that new environment. Right? That is the one of the core issues you have to deal with in agentic systems. Today, there is a lot of emphasis on something called ambient agents. What are ambient agents? I like this. I put this picture. I used to have a golden retriever who lived with me from my childhood, all her life, 14 years. She used to sleep next to me. I would be sleeping, she would be quiet there, sleeping. But somehow, she could sense when I'm about to be awake. Maybe my breathing pattern changed. Maybe there were some uh, observational signals, and her sensors would immediately catch on to it. Right? Apparently, dogs can smell that you are waking up, or they can hear the change in the rhythm of your breathing. She would. And so by the time I realized I was awake and I would open my eyes, what would be the first thing I would be seeing? She would be all over me, right? And she's all like, okay, let's go for a walk. Let's go for the hike. She's all ready to get out because that's what we used to do, go out first thing in the morning. So what is that? It's a ambient agent. doesn't disturb you while you're sleeping, but listens to crucial signals and acts upon it. We carry it these days in our hands, right? In a way, what does this do? It doesn't bother. But the moment we have a precipitous fall and it detects that we have fallen and we are not getting up, what will this thing do? What will a smart watch do? Start calling your loved ones and, if necessary, call 911. Isn't it, guys? So that's an ambient agent. You can have more practical ambient agents on a factory floor looking for things that shouldn't be on the floor materializing because they fell off a shelf or liquid spills, right? And generally, they are in observational formation. But the moment they observe this, they come swooping in with corrective measures. Right? We'll see a massive proliferation of ambient agents in this year and the years to come. The dominant agents will be ambient agents doing their job while we sleep or while we are doing other things. So there is also a renaissance. Go ahead. Oh, of course. If you visit manufacturing today, uh, the factories of today are nowhere near the factories of yesterday. The mental picture people have of factories in the 20th century is that vast armies of people would come, fill up the parking lot with their cars, then dutifully march into a factory and do their work, right? And there'll be massive coordination with the army of supervisors and whatnot, planning, doing things. Today's factories are dark factories. I don't know if you know. In the great manufacturing hubs in South Korea, in China, etc., you go to a massive factory spanning maybe 1 million square foot, you will not find a single human being. Everything is controlled by robots and physical AI. Already it's happened. Yeah. In fact, they're called dark for a reason. There is no reason to turn the lights on. They don't need light. So there's actually no lights on. Imagine 1 million square foot factory humming along in high productivity, completely automated. And the moment a contingency condition arises, in swoops the corrective measures. So these things are all very real. Physical AI and ambient agents are very, very real. We live in the world of multi-agent system. Teamwork rules. There's no doubt about it. Like teamwork makes things. But interesting thing about multi-agent system is something people tend not to know. It's called emergent phenomenon. Emergent phenomenon shows up in dynamic systems which follow certain characteristics, but agentic systems fall in that category. See, how many of you have driven down Interstate 5 and seen the scene that you're seeing on the screen? Something like it. Birds having this formation. See, each bird is an autonomous agent, has autonomy. It does whatever it wants to do. But the overall collective flock goals and operation leads to things that globally lead to emergence of interesting patterns, isn't it? And many a times I've seen people doing good agentic systems and then being surprised and saying, hey, did you know what we observed that when the whole thing came together, this came as a bonus, unexpected bonus. We could see that our agentic system is now able to do this. That's when you know that you are creating powerful and meaningful agentic systems. That's almost a telltale sign of that. So I won't go into that. You have specialization. It's very interesting. I will just bring up one person. Uh, Many of you remember this movie, Beautiful Mind, John Nash. Right? So Shapley was actually a classmate or a peer and friend, close friend of John Nash. He recently died. He got a Nobel Prize. He did prolific work, but he got the Nobel Prize for one interesting idea. While John Nash worked on adversarial games, zero-sum games, Shapley worked on cooperative games. Teams are inherently cooperative game, right? A boss says, next release, I want this feature done. You as a team get together. Oh, let's do it. And there's a guy who'll test. There's a guy who'll do project planning. There's a guy who'll code, right? Another guy will architect something or the other. We all work as teams. What happens when the team concludes that somebody is of no value? The person disappears. In other words, every team member has to earn his or her keep in the team. Are we together, guys? Right? Or whether you're playing soccer or any cooperative game, these rules apply. So Shapley answered a very interesting question, which is at the heart of agentic systems. People tend to bring in lots of agents into a system because they can or because they think it is useful. How do you know that you have not overpopulated your system with too many agents? That's a question worth asking, isn't it? Because complexity comes with a cost and it can be counterproductive. The answer to that comes from, actually, I like to answer it with Shapley values. He wrote an equation, which is the famous Shapley value equation. It ascribes, actually, let me tell it to as a joke. Let's say that your team did great work. And because of that, the organization says, okay, 1 million bonus for your team. Tells the manager, here's a 1 million bonus, distribute it in your team. There are multiple ways of distributing it. A pure socialist approach would be equal division. Let's divide it equally. Is that fair? Anyone? If you always divide the rewards equally, what will it lead to? Gradually, everybody will do the least necessary to just exist in the team. And that was, those of you who remember India's history and socialist years, you remember that some of the government jobs became like that. People did the minimum required to hold on to the government jobs. Right? So that approach doesn't work. There is the other non-socialist, but I suppose the capitalist approach. The manager pockets the $1 million, then goes to the team and says, great news. This cycle, nobody is going to be laid off. Be happy. Right? But the $1 million goes to the manager's pocket. Believe it or not, it happens more often than you know. Not to that extreme level, but it does happen. But the question that arises is, what is the fair distribution of that? And it turns out the great work of Shapley answers that question exactly. It's called the Shapley value. It's the fair. We are not looking for equal division of the reward. We are not looking for the other extreme. We are looking for fairness. So he defined fairness of reward distribution using a famous mathematical equation, which was partly quoted for his Nobel Prize. So you should ask yourself this question using exactly that analysis, Shapley value analysis. What value is my agent bringing? If you do that as part of your ablation studies in your agentic system, you will never overcomplexify your agentic system. So I thought I will just bring it forward. Flawless collaboration is a given. Good surgery, you can see that those surgery theaters, those surgical teams which have flawless collaboration have a far higher, better statistics. They have far lower mortality and morbidities. Right? There is a paper that I invite you to study. I'll just give you the title. Generative Agents, Interactive Simulacra of Human Behavior. What people did, this was way back in spring 2023 when ChatGPT had just come out, right? GPT 3.5. One group of researchers at Stanford, what they did is they created a village, an environment, village. They populated with human-like figures, chemist, professor, student, politician, etc. And they asked these agents to live out their life. The goal was live out your life, live out your roles in the village. So as they lived out and as they interacted, one of the most remarkable things happened. a lot of human behavior emerged. It was the emergence of very, very realistic human behavior. That's why the title, Interactive Simulacra of Human Behavior. Simulacra means imitation of human behavior. And that paper, while despite its technical simplicity, all it did is using prompts, created a handful of so called digital human beings, lived their life in an environment which is a village, Smallville, and the implications were so vast that this paper is read in many disciplines, sociology and many far off disciplines, psychology. This paper is read, and it is, I believe, the second most quoted paper in the field of AI agents. Right? It has the highest number of references. But I'm just bringing out the power that AI agents have, right? When done well. I won't get into the rest of it, but I want to talk about now, go a little bit deeper and talk about the core agentic pillars. To hold up an architecture, to hold up a cathedral, you need your core load bearing pillars. What are the load bearing pillars in the agentic system? Remember, I'm using the word agentic systems, never agents, never one agent, because good engineering is about systems, not parts, right? Architecting systems. So, to architect systems, agentic systems, what are the four pillars we need? We need programmatic prompt optimization. I happen to, it's my role as as a support vectors AI research and training lab, often to give advice to a lot of companies and their agentic implementations, agentic systems. Quite often, I find that they have missed the first pillar itself, the prompt optimization. There is no trace of the prompt optimization. So we'll talk about that. The second important pillar is the empowerment of tools and using standardization around tools. Again, we'll talk about it. The next is fine tuning and reinforcement learning. The ordinary fine tuning, supervised fine tuning, and in particular, reinforcement learning now is getting dominant attention in agentic systems. It is an irony that we have come full circle because the theory of agents literally arose, the vocabulary, the language arose in the context of reinforcement learning. And now we are full circle back. Planning and multi agent orchestration. I suppose I hardly need to mention that complex task alone should be done with agent. If it is a simple task, why would you need an agentic system? Complex tasks need planning and careful orchestration. Hardly needs to be said. So let's go over each of them one by one. How many of you know what do I mean by prompt optimization? We all know what prompt engineering is, right? You sit down and write lots of text. The prompt. Do we understand what prompt is, guys? What is prompt engineering? The crafting of that text, right? When we create an agent, you typically create a text and you instruction and you give it to the agent. It becomes the character of the agent. You tell the agent, you are a logistics expert. Then you give it some task to do about supply chain. Am I making sense? Or you are an amazing writer. Now write me an essay on this topic. Something like that. So the characterization, the role ascribing is all under prompts. One metaphor that helps people is think of these language models as 1,000 PhDs. Remember, they have read everything under the sun, right? So imagine a curtain behind which are 1,000 PhDs. So the first thing your prompt does is ask the right PhD to please step forward, isn't it? And pick up the role and give it a task. So prompting is given. You often hear people saying, hey, in our company, we have created 50,000 agents. Quite often it means they have written 50,000 prompts, isn't it, guys? Right? And is that prompt coupled with the LLM and agent? Right? Maybe with a couple of tools added, prompts, LLM, some tools. Does that make it an agent? Yes, it does make it an agent. It's a bona fide agent, but there is a vast missed opportunity cost. What is the missed opportunity? LLMs are extraordinarily sensitive to the text you write. And the way and there's a whole technical aspect. Can I dip a little bit into the technical landscape? See, what happens is your texts become vector embeddings. Those vector embeddings make their way through the large language model. Through that, there is an extraction of the intent, the semantic core of the text. As vectors are there, you would agree that even small replacement of one vector with another can have profound implications on what comes out the other end. Isn't it? And it is an observed thing that responses of LLM are extraordinarily fragile and sensitive to textual perturbations, textual changes. Is that an observed thing with any one of you? It's basic prompting. You don't need to know agents. But based on how you ask the question to your chatbot, you get different kinds of responses. So that brings us to the core. How do you discover the best response, the best input or the prompt? So think of focus groups. The intuition is you think of focus groups. When you build a product, don't you create lots of variations of it and then show it to focus group and say, is this one better? Is this one better? Is this one better? Do we understand what focus groups are, guys? Politicians do it all the time. The politician will say one thing. First promise you $1 million. See how many people liked it. Nobody believes you. Right? Then you change it. Oh, we'll give you $1,000 to everybody in this community. It leaves more believable. And then you say, okay, now the politician goes and gives a speech. Because of this program, every person under this category will be given $1,000 or a free bus ride or something like that. Why that particular thing? It came out of the focus groups, right? That's the concept of focus group. So now what happens? You want a certain result from the LLM. Given the text, you can create 1,000 variations of it. Each variation will elicit a different response from the LLM. Does that make sense? Now you can pick the best of the breed. Except that it's not practically humanly feasible to create 1,000 variations of the text. You will create 2-3 variations and get tired, isn't it? But there is a programming. One of the part of this is there are programming architectures that help you do that. Those things that programmatically discover the best text, the best prompt that stably, consistently elicits the right responses from the LLM for that task, obviously creates better agents. Would you agree or not? So having created the engineered a prompt, you must go through the journey of prompt optimizations. Very mature tools exist, right? That is what it is. So this is the journey from prompt engineering, one second, which is an art. Right? People write prompts, good prompts. And engineers are usually bad communicators. So people with English majors, etc., would often write much better prompts. But now we have automated prompt optimization. There's a scientific way to discover the best prompts. And does it look like a no-brainer, guys, that given that these architecture, these tools exist, if you are building agentic systems, you must have this as a core pillar? And isn't it a shame that a vanishingly small proportion of people doing AI agents even know about it, far from doing it as a regular practice or having it as a core pillar? Your question, sir. See, when we think of an agent using generative LLMs, what happens is the agent is the coming together of two things. The LLM, so you can pick a better, good LLM, but given that LLM, what is the best version of the instruction prompt? And prompt optimization is the process of systematic discovery of the best instruction prompt. No, the goal part is easy. And maybe the prompt optimizer might rewrite the goal itself in better language. That too is part of the prompt and it may happen. No. Yeah. Generally, see, there was a time, what you are alluding to is a period at which the tokens were expensive, and there was some body of effort that went to prompt condensations, right? Or prompt compaction. By and large, I don't see that being practiced that often anymore because the token prices are falling catastrophically all the time. Especially in agentic systems, you tend to use a lot of local models. So the price is zero, more or less, right? So expressive prompt optimizations primarily focus on expressivity, lack of ambiguity, clear articulation. But if you so choose, if you are price sensitive, you can add it to your prompt optimization as one of the objectives that also achieve all of this with the least number of instruction prompt tokens that it will fulfill it then. Yes, and thank you. I'll just state, I hope all of you heard it. And thank you for contradicting me because I knew when I said that, right, that I was taking you all for a ride. You're right. See, foundationally, if you look at the attention equation, it's a k dot q, it's a quadratic cost. It is quadratic in the number of tokens. That quadratic cost in a local LLM manifests as latency. It manifests as compute resources, GPU resources being engaged, right? And even when you do more practically KV caching, nevertheless, I mean, you may KV cache the instruction prompt. Nevertheless, the situation is ameliorated, not cured, right? You do pay computationally a performance overhead for very long uh, tokens. And to your point, I have seen, I was advising a medical group, and I noticed that they literally, for a system prompt for an agent, was in the order of 150,000 tokens. They felt they needed to do that. One of the exercises we did was to excise that and put it into a RAG system, into a vector DB, and make sure that all the pertinent information is nevertheless passed to the LLM. Large tokens have other problems. There used to be the problem of lost in the middle that has been cured, but there is still the problem of context rot. There is another problem of bookends, which is that LLMs tend to overemphasize the beginning and end of your instruction prompt, less than the middle, right? Just this week came out a paper with yet another remarkable twist. It says that any LLM does, without making any further improvement to it, if you just repeat your complete prompt twice over, you get a disproportionately large performance gain. And now, and it sort of makes some arguments. I'm not fully convinced of those arguments, but empirically, you can't argue with the fact that doubling the prompt, the instruction prompt, has led to, just repeating it, has led to better results. And so, with all of that, if you write very long prompts and you also choose to double it or repeat it, you are asking for trouble. So, yes, your point stands. So, anyway, so that's the that's the, and there are many frameworks. DSPY is the poster child, but there are other ones that are heavily involved in this space. So, what's the raison d'etre for prompt optimization? You maximize performance from the frozen model. It is the cheapest thing you can do, guys. To fine tune a model is expensive, resource intensive. You may not even have the hardware or the technical know how in your team to fine tune models, but surely you can prompt optimize. In more technical language, for those of you mathematically inclined, and ignore the rest of you ignore it, before you think about changing the latent space of a model, to fine tuning, why not explore the latent space to find out its optimal use, right? That is it. And the technical term is it's latent surface exploitation. We are not changing the model. We are mathematically searching its existing high dimensional surface to find the precise vector that triggers the optimal response. Right? Putting it in a more technical manner. Now, now we move on to tools. Yes, go ahead. Oh, what does it mean? Anyone? It's a French word for reason for existence. Raison d'etre, you tend to bring up the phrase whenever you say, okay, why do I need this? In simple terms, in engineering, right? You always have to ask this question, why do I need this? So instead of saying that big verbose phrase, you can say raison d'etre. So that's that. Now we move to tools. Why do we need tools? And an easy way to answer that is just imagine that a brilliant cardiologist is visiting his hometown way back in the old world in a village. There are patients. Somebody has a problem. Do you think he'll perform brilliantly there? Probably not. Versus a cardiologist looking at patients in a university hospital teeming with tools. Which of the cardiologists would perform better? The one in the university hospital setting, isn't it? The same cardiologist, when comes back from the hometown, the home village, back to the university hospital, the intelligence is manifest in action. Would you agree? Accomplishes the goal better. Cannot accomplish that quality goal in a remote village without tools. And thus the value of tools, the empowerment of tools. Right? It is literally that. In the university, you call him a state of the art hospital, you call him a miracle worker. So the main goal is tools give the brain hands to actually act. Right? In simple terms. Empowerment of tools, frameworks like, oh no, sorry. There are many toolings that are there. This phrase shouldn't be here. Lots of tools, code interpreters, right? Search is a tool. Image generation, knowledge base, RAG is a tool, audio is a tool. You do that. Now, tools can be many. If you look at the systems, in computers, guys, there are many tools. You have a computer, it's the brains. But soon you want to attach a keyboard, you want to attach a mouse, you want to attach a printer, a scanner, a camera, right? Speakers, all of those things. Now, what if every one of them had their own particular interface, right? And every computer wanted its own declared interface on how things should attach to it. There would be chaos. Enablement comes through standardization, isn't it? One of the things that USB did is made it so easy to empower computers with tools. Does that make sense, guys? What USB did to computers and the use of peripherals, MCP, a standardization for tools in agentic systems does for the agentic systems. Right? Think USB for peripherals. That should be the mental model. And it decouples the model from the tool. So the raison d'etre is clear. To build the hospital once, you can drop any doctor. If you have standardized equipment in the operating room and the consultation room, any doctor can walk in and know how to use those tools effectively, isn't it? That's it. That's what it is all about. And the next tool, the next pillar of the 4 pillars of agentic systems are what I call fine tuning. Fine tuning is deep surgery. See, if prompting gives an employee a better handbook, fine tuning is sending the employee to medical school or to fundamentally change their thinking. Upskilling. Fine tuning closest resonances to the concept of upskilling or re education or further education. There are many ways of doing it. Think of it as parenting. And so, if you do it using reinforcement learning, you use degrees of rewards. If you do your homework, parents tend to bribe kids a lot, isn't it? If you do your homework, you'll get dessert after dinner. If you managed to get 4.0 in this quarter in everything, oh, we might consider getting you a used car, right? So that's how actually, believe it or not, that's how models are trained. So the shift is from contextual stuff to muscle memory. You change the internal architecture, not the architecture, but the shape, the latent space of the model itself. And that. And quite often you can achieve similar results. People often say, because of RAG, fine tuning is dead. But then people say, because the context window is so large, RAG is dead. Don't, in our world of AI, one thing is for sure, experts are every day declaring the demise of all the key components. Right? So beware of such statements. They're nonsensical. So the strategy, remember, fine tuning should be the method of last resort. It's hard, it's dangerous. Why is a neurosurgeon paid so much money? More than, let's say, a skin surgeon, dermatologist. For one simple reason, every act of a neurosurgeon in the brain is irreversible. You can't, you don't have a control Z, you don't have an undo button, right? And every act leads to some damage. You have a tumor deep in the brain, no matter which path you take, there is cognitive loss, there is functional loss. Not many people realize that every time you fine tune a model, you don't gain something free. Something is lost. And you have to ask, what is it that you're willing to lose that doesn't matter for the task that this agent will do? Right? For those of you who are more mathematically inclined, what I'm saying is, uh, for any given input, LLMs produce a probability distribution over the tokens. There's a conservation of mass. All of those weights have to add up to one. So if you just make one place more likely, you change the probability distribution. That mass has to come from somewhere. Somewhere there's a mode collapse. You just have to know what you're losing. It's one of the points about fine tuning that most people fail to remember. That you're shifting sand, the probability sand. You are therefore amplifying some ability at the expense of something that hopefully is not relevant. Right? And if you're not careful, you can actually have catastrophic forgetting of crucial abilities. So fine tune the model for long enough or with too much data, it will realize that, oh, that which I remembered was wrong so far. Let me change my perception of reality. Right? And it will have catastrophic forgetting. That's what makes it dangerous and makes it like a neurosurgery because there's always loss. See, from a deeper perspective, a morphism of the model's latent space itself, of its behavior, structural aspect, is more durable and oftentimes remarkably more effective, especially for domain adaptation or for inducing new abilities. Right? If you think about it, DeepSeek, when it came out with the first open source reasoning model, it was achieved through fine tuning. You took a pre trained model and you did a lot of reinforcement learning fine tuning, and voila, it's begun to reason. A remarkably new and powerful induced ability. So that's the power of fine tuning that you have. Then planning. Agentic systems are more and more getting focused, and research is focused on planning. Many people who build agentic systems will tell you, researchers will tell you, that planning is where they're creating agentic systems through RL, through reinforcement learning. To plan better is the heart of it. Right? So plan, execute carefully. People say in real world, right? Measure twice, cut once when you talk of ropes, especially when you do bungee jumping. Right? Similar thing applies. Plan it very carefully. And agentic systems should do that. So that is where when you think of workflows, moving from stateless QA or, you know, flow diagrams to go to a stateful flow diagram and intelligent flow diagrams, that based on what happens, what the current state of the environment is, the workflow changes. So if you ask what's the difference between a workflow and an agentic system, the difference is workflows before agentic systems were baked in. Some developer, somebody built the workflow. There were even, you remember, many of you may remember things like BPEL, business process execution language. Does that ring a bell in anyone? Right? Those were there. What were they trying to do? Block diagrams, and we do that. You can think of it as proto agentic systems. The ability to reason over the current state was missing. The difference between, come again? No, business process execution language is different. Yeah. So agentic systems differ in the sense that at every given moment, it can observe the state of affairs and fluidly change its workflow. Right? Come up with a new workflow. If you don't give that, and a lot of people who create agentic system, you look at it and you say, I ask the inevitable question. So where is the agency? You people create, they write code using prompts. So I often say that what they would have done in C, C++, Java, Python, they just happen to be doing it in English. Right? It is baked in workflows. Where is the agency here? Just because you used an LLM doesn't mean it has agency. You used an LLM for a linguistic task, but your workflow is still static. But the power of agents comes from fluidity of the workflows at inference time, right? At execution time. That is it. So that is the distinction between workflow and agentic systems. Agentic systems inherently have agency, autonomy, and they can, at inference time, in the flow of action, completely change its direction and pivot. So planning, memory, and orchestration, you end up with cognitive architectures. I hope that sentence now makes sense, right? It will think before it speaks, before it acts. It will manage context and so on and so forth. So, solving, so raison d'etre is you can't solve multi-step ambiguous problems with just a simple zero-shot prompt. You need to plan it out, and then that agent will then come up with, even it may even write a prompt to fire at another agent or another LLM, right, in a multi-agent collaboration. That goes on. So where are they used, guys? I hope I don't want to go. I shouldn't go into this section. But the question is, where are they not used and why? We are in 2026 now. More realistic question is, where are they? So I'll tell you, the cliche of all agentic tutorials is travel agency. Have you seen those tutorials? Any one of you? Actually, travel agency, in my point of view, is the anti-pattern for AI agents. I'll tell you why. Most of these tutorials, they will search the web. They'll have an agent that will search the web for prices, for hotels, for flights. Guess what? They are gathering sticker price. The whole point of a good travel agent is they have special deals with airlines and hotels. Right? They'll give you the unpublished price, negotiated prices. And you get, like, for example, I traveled to India because I have little getting old now and back gets tired. When I was young, I used to travel economy. Now I travel business class. Business class prices, especially if you want a full flat bed, are notoriously expensive. Try Googling it up. It will come out at 7 to 9,000 for a round trip. How much does it cost me when I go through my travel agent? Give or take 4,000. Right? What a vast difference. So, for heaven's sake, the basic litmus test of an agentic system should be it should do better than human agents, isn't it? Don't create an agentic system, say, I have a travel agency, use it. And then people are buying tickets. I mean, I'm sure the airlines and the hotels would love it. Perhaps that's the reason it shows up in every agentic tutorial. I'm kidding. Right? So know when to use it and when not to use it. Customer support, almost every enterprise that I know it are building AI agents for customer support, marketing, sales, and so forth. It's a no-brainer. For collaborative work, for deep research, agentic systems are amazing. News gathering, for virtual teaching is being revolutionized because of the use of AI agents. In some countries, far more than in other countries. China, for example, has deeply imbued AI agents into their classroom, and the impact of it is phenomenal. Wait 10 years and you will see the visible outcome of that transformation. So, education, agentic systems have health and wellness. How often do you go to a doctor? You go to a, suppose you have diabetes, you go to a cardiologist. He says, hey, you be careful. Don't run, don't jog. Your heart is not that, it will put too much pressure on your heart. Then you go to the diabetologist and he says, you need to exercise to lower your sugar. Go take a good run every day. Does that happen, guys? Do you get contrary advice sometimes from specialists? Right? That is one place where uh, they each are right, but there is a balance in between. Maybe if they both talked, they would come to the conclusion that, hey, make sure you walk 2 miles or 3 miles a day gently. Your heart doesn't get too undue distress or stress, but at the same time, you have enough workout to help with your diabetes. Does that make sense, guys? In practical example, how can you do that? You can do that by having a multi-agent medical advisor that has the virtual cardiologist, the virtual diabetologist, the virtual arthritis specialist, and so forth, all together talking, forming a consensus, and presenting that consensus for final review to your primary care physician, right? And also sending it to each of the human experts that this is the eventual advice we are going to give. Would you please approve it? That would save everybody time, isn't it? So all the experts now can weigh in, read and weigh in all the factors considered by other experts or point of view of other experts, and then quickly come to a consensus. One of the reasons that Mayo Clinic and Cleveland Clinic have had such a high success rate with patients, you know that in US, medical hospital systems are a disaster. Most deaths happen not from cancer or heart disease, but because of medical errors in the hospitals and literally bad advice and bad actions. It's, it's the biggest epidemic. In a country with failing medical system, a catastrophically failing medical system, every time they make more mistakes, they charge you more on your bill. Right? In such a country also exists this brilliant, wonderful hospitals like the Mayo Clinic system and the Cleveland Clinic system. What is the differentiating factor? Why are they doing so well? They actually do exactly this. They say that for every patient, they will have a committee of experts coming up with a unified recommendation, unified plan of action. That's how they act, which is why they have such an extraordinary success rate. Right? And people travel from all over the world to come to this and get treated there. So the values are real. Supply chain is a no-brainer. Intelligent cities is a no-brainer. So again, multi-expert collaboration. There actually was an incident in India where there was typhoid that spread. And when they looked at the cause, it turned out that the main water pipe was a few feet below or proximal to the main sewage line. Is that a recipe for disaster? Can something go wrong? Right? Why? This department isn't talking to this department. They're independently doing stuff. Right? But what in when you design cities with complicated facilities, that is exactly the place where agentic systems shine. Right? They can prevent such blunders. Broader use of agents, factories, AI factories are doing it. Of course, unfortunately, we now live in a world in which all the wars will be fought with drones, AI agents. We're already there. As you know, the wars of 2025, many of them, battles or engagements, were drones of one system, AI agents of one system fighting, one country fighting the AI agents of the other country. We live in the world of AI warfare now, unfortunately, for better or for worse. So there are many open source AI agentic frameworks. The AutoGPT I code because it's the oldest. It has also the highest number of, last I checked, it had, that's a very high cost to pay to get our jobs back. Okay. So yeah, AutoGPT, because of its simplicity, is the most popular agentic system, close to 200K stars. But for enterprise use, it's not of much value. Its main benefit is the simplicity of it. Then you also have, NA10. If you want low code, no code agentic systems, go with NA10 and so on and so forth, drag and drop, and you're done. Very, very empowering. So if I may give you one advice today evening, just go play with NA10, right? Or any such no code, low code systems. Then there are Lang graphs, Lang chains. Crew AI is one of the very popular multi-agent system. They were very popular, though their popularity is somewhat stagnating recently. You have AutoGen, again from Microsoft, which also very popular, but I think it's stagnating. So they are the first generation of agentic tools. I personally have gone through all of them, and frankly, I don't use them anymore. Right? Uh, PyData, Agno is there, Llama agents are there, many such. Burr is, by the way, an excellent tool, though its perspective is a systems approach, an operating system sort of an approach. Very reliable execution focused. So NA10, as I said, is easy. Langflow is another drag and drop system. Pydantic AI. But the ones that I didn't mention in the slide, the real ones, I thought I'll just speak. These days, there's a convergence, guys. And let me end with that. See what people realize. Look at an operating system. What does the operating system have? A compute unit, arithmetic logic unit, and memory. Compute, CPU. It has memory, volatile memory. It has persistent memory or storage. And on networking and on the fabric of it, what do we have? The operating system layer has the scheduler of processes, isn't it? Access to the file system, right? Access to network, access to various peripherals. Now map it to the agentic world. Do we need memory in the agentic world? Yes. Do we need compute units? More than so. In fact, unlike a dumb compute unit, we are talking of very, very powerful neural networks now that can reason. We have true reasoning compute units. Do we have uh, persistent storage, like knowledge stored or fact stored in persistent storage? What is that? RAG? RAG as a tool, right? Vector databases and so forth. Do we have tools? Galore of tools. RAG itself is a tool, right? Your scratchpads, your everything. Web search tool, this tool, that tool. Do you see a near mirroring of functionality? So would it be terribly unfair or out of the way to say agentic system is an operating system? A good agentic system should be an operating system whose core hearts, the processing units, are deeply intelligent reasoning systems that observe, reason, plan, and act. But these agents, they roughly map to processes, right? And they can be scheduled, their orchestration, just like an operating system orchestrates process, their orchestration roughly maps to the scheduler of an operating system. That is the emergent thinking now. And so a new genre of agentic systems are coming, which are beginning to show those characteristics. If you look at Google Agent Development Kit, one of the reasons I like it very much is because it resonates more than other systems with this ethos. MCP also is like that. In a Unix system, you realize that a Linux shell or a Unix shell, what is it? Lots of little tools, sed, awk, grep, ls, find. Do we use those tools? And yet you can easily concatenate those to create tiny one-line scripts to do powerful things, right? So a similar, you see a resonance of that to a tool maximalist perspective of using lots of tools to getting a work done. So what was your one-line piping of Unix commands? Does that look like one agent coordinator working with so many tools to achieve one goal? Do you see the resonance between the two guys? And so the new thinking is that. So what I observe, so now I'll end with a subjective statement. What I'm observing in the industry is uh, everybody is donating. They say that many agentic systems have come. They come and they go. I have not given you the full inventory of agent orchestration systems. Too many. And then people are realizing, let's do it the right way. Linux Foundation is the guru of operating systems, isn't it? You feel like competing with Linux? No one wants to, right? Even companies like Microsoft that used to call Linux, what was it called? Toxic or poison for the enterprise. Today, their Azure cloud runs more or less 100% Linux, right? And GCP is 100% Linux and more or less near 100%, and likewise Amazon. They have Windows, etc., but sparingly, right? So, in the same way, people are saying, let's move in that direction. And who best to give it to spearhead than the Linux Foundation? So let's create an AI alliance on and give it to them so that we all stay neutral. We give our best ideas and let it be the agentic systems of tomorrow, orchestration frameworks of today and tomorrow. It's already happening, so I should say it today, but more so tomorrow will have a much stronger resonance with an operating system. And it is being steered now through a global collaboration. So companies are not competing. They instead have decided to collaborate on creating the best agent. MCP has been given to it. The agent to agent protocol and the agent development kit from Google has been donated. There are other people who are donating different things. So there's a great convergence and collaboration that's happening, right? Which is an interesting parallel. Human agents are collaborating now collectively as a human intelligence system to create human agent system, all for the purpose of creating the best AI agentic system. So with that, I would end the discussion part, guys. I'll take questions, but I would like to give you a demo of our agentic product. Are you guys game for it? Right? Any questions before I move forward? By the way, was it useful or was it too fluffy? Okay. Yeah. All right, guys. Do you need a 5 minutes break? Okay. Then we'll start with the demo. And that demo is what we will build tomorrow. Right? We'll do the code walkthrough for tomorrow. I'll give you the case. We will build this product, or rather walk through its code tomorrow. It's a somewhat useful agentic system. What it does is this, the use case, practical use case. It came from a real use case, actually, which I've adapted by removing the client's identity, right, or anything that would impinge upon the IP. This narrative is this. Employees write self-reviews every once in a while. Performance review cycle comes, you write your review. When you do write your review, it is, how many of you enjoy doing that? And it's like engineers rarely like writing self-reviews. And then some people will write 3-4 lines. Some will write a whole novel there, right? Some will be very factual, blow by blow by blow account of how exactly in countless ways they have saved the company, right? Others will just give a high level, yeah, I did my job, right? Things like that. So there's a wide latitude in the way people write self-reviews, despite companies putting some sort of a control, some things that this is a checklist of things, this is how you should write your review. It happens. So what we created is, and then for managers, if there is one thing you hate doing is sitting and reading novellas for reviews as a manager. Most of you, and one of the things I noticed is as I moved up the corporate hierarchy, I noticed that my direct reports would write longer and longer self reviews. Right? So that's quite interesting sometimes. So we will create a tool that will be of use to three people, three personas. The employee, it will give guidance on whether the self review they wrote is good, or whether, or help the employee shape and write an effective self review. Would that be useful? It would also be useful to manager, because they can see they can extract a signal from the file and remove the noise. So it will give the key achievements in a table so that you can quickly see what the achievements is, contextualized with projects, right? And it comes up with a summary scorecard. Upper management loves scorecard. Reduce it to 3 or 4 numbers, right? We'll try to do that. We'll try to create a word cloud out of the self review and summarize the review, just in case you found a novella there, right? Summarize it. But we'll start simply. See, guys, when people write reviews, many people are native English speakers and they write good English, or they pass it through Grammarly or something like that, cleaned out language. Most of us write reviews. I'm a non native speaker of English, which explains why my spoken English and written English are both very, very defective. Right? So, what's our salvation? These days, we tend to pass it through some LLM or something. But now, in this tool, we'll make it do that. You should assume that a text will contain typos, incomplete sentences, needs clarification, needs rationalization. So, the very first thing, so the user has entered a small text. Would you consider the user has written a nice and detailed self review? No. This is like, oh my God, I need to do it. How quickly can I get over it? Right? And it's just fulfilling a ceremony, written that. What we do is, first step, we'll rationalize the text. The rationalization of the text is cleaning it up, capturing the intent, and restating it, removing typos, but not factually changing the text, not changing any factual claims. Semantically, it has to be identical, but should be more readable. Right? It turns out that all agentic systems should do that. Your chat GPT, have you noticed that you can give to all these chatbots, frontier chatbots, absolutely massacred language with lots of typos and half sentences? Nevertheless, it is able to infer what you're talking about, because the very first thing they do is text rationalization. They canonize the text. So we do that. And when we do that, would you please open the streaming events part
Okay,
in this
because I
question?
had it has finished it, no? I have to
Okay, so
restart.
go ahead.
I'll rerun it.
Okay.
It's okay, let me rerun it.
So what
When I
happens is this agentic system is launched, and as you can
once
see,
it is finished, no, the streaming is wiped
it's
out.
gone.
But
Okay.
yeah,
Yeah,
I didn't want to wait while running when you're presenting. So I did a run, and this is the output.
this is it. Nice. So what you're seeing is the agentic system, as it is working, it is declaring what it is doing. That speaks to observability and traceability, right? It should be observable. Logging, observations, traceability is important in agentic systems to
Yeah.
have that. Right? Then there's a raw JSON, etc. The next thing is to summarize. Well, this text is so short. Do you think it needs further summarization? Probably not. So a good agentic system trying to figure out what is written there has, to the best of my understanding, actually summarized it to a bigger text, which is an oxymoron, but okay. We go to the word cloud. Okay, it's talking about this, that, etc. It gives you a gut feeling of what this user has been up to. Let's look at the achievements. So when you write your review like that, the AI is achieving core, like, it's like the KPIs, like some real achievements, objective things. What have you really done? And what is the impact area? What is the contribution? That's what you really want to know, isn't it, guys? As a manager, quantify, make it objective. And it has done that. And now the next is a review scorecard. And as you notice, when you look at it from an organizational perspective in reviews, what you want to focus on is what has this guy actually achieved, materially helped the organization? What is the outcome of this guy's contribution? Not noise and activity. I did this, I did that, I did that, I did that. And at the end of it, so what came out of it? Actually, nothing worked. Right? That's a different, substantively a different kind of employee than an employee who says, who has many, many outcomes, can say 10% increase in revenue because of this feature I implemented. Wouldn't that be better? Or 16% reduction in bugs reported, runtime, production bugs, or something like that. Those are material outcomes. So, so on the outcome over activity, pretty low. Quantitative specificity is very imprecise. Clarity is not so good, reasonable. Conciseness, yeah, certainly a winner there, right? Ownership and leadership, like basically how much do you show ownership and initiative and leadership? Again, not too good. What we will do, but observe what this
And
agentic system has done. It is guiding the employee. It says there were issues found with the self-review text. Please study and fix these. Don't submit this review. Right? Looking, if the user is still not convinced, it says there are too few achievements found. So either that's the honest truth, or you haven't written your self-review carefully, isn't it? Elaborate solution, elaborate on the details, and add measurable achievements. Then try again. So would you consider this tool mildly useful? Right, to that, and useful to the manager also, because they get a proper table of achievements and a scorecard, right? So now let's take a better written review. This says this was my role, this is the period, and just just eyeballing it, you get a sense. What do you get a sense? It is written. Do you also see that there are numbers, factual numbers, quantitatives in the review? This person is talking numbers here. 43% reduced from 3 days to 1 day, right? Uh, this and that, from 48 hours to 6 hours. So let's see what the AI thought of it. Let's go to rationalize text. It cleans up the language, didn't need too much, but it does clean up the language. Then it highlights the achievements, goes to the summary. When you look at the summary, guys, what does it give you? Hard metrics, isn't it? For a manager in a rush wanting to know exactly what was achieved, it starts with that led major upgrades to the checkpoint or checkout data pipeline across blah, 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 replacing a slow, the main airflow improved, etc. Would you agree that this talks about outcomes more, guys? Right. So let's go to the word cloud. Contains the word clouds, data. It's all about data and features that this person is working on. And in S3, so you know that this guy was busy with the cloud, Amazon cloud. Let's go to the achievements and look at that. How many of you, by the way, as a manager, would rather have all your reviews, your employee reviews, team reviews converted to a table like this? Anybody finds it useful? So we have converted that. And so this is the value of creating agentic systems. Right? Using a good reasoning agent, you can do. It has a whole table of metrics, Q1, Q2, H1, this time period, achievements, like contribution is critical or minor. It gives you some sort of a ranking, impact, delivery speed, etc.
some of it came with a RAG also, because we do have details on each project being mentioned in the
Yes.
text.
Yeah, thank you. Actually, Chanda, thanks for bringing that very important point. See, what happens is that suppose you were the key contributor, critical contributor to the most insignificant project. Situation one. Or you were a key contributor to a high impact mission critical project. Are the two equivalent? No. Right? This has more, obviously, from a Shapley value perspective, this has more value to the organization, isn't it? Therefore, one needs to do that. How would you do that? See, the moment user mentions in the review any project, a good agentic system should do what? Dip into the knowledge base, figure out what is this project, the project document, what was it, what were its goal, how important was it, and then contextualize the achievement with respect to the project documentation. So this agentic system that I'm giving you guys does that. Huh? So this is the scope of the project that we built, the application that we will tomorrow walk through the code base of. And hopefully then you will take it and extend it in your own way. Does that look like a fair game, guys? We'll do it using multiple agentic systems, using Creo AI, using LangGraph, and using Google ADK. And a lot of the tooling we will do through Model Context Protocol. So everything that you heard today, me talk about in narrative form, we will see it reified in actual code and real implementation. So let's keep that for tomorrow. Right? So guys, thank you very much for being here. And did I invite you guys to my bootcamp yet? Okay, the QR codes are on the wall. Sorry for the marketing, but it starts next Sunday. Those of you
You
who are finding this interesting, please do join that. One
So,
thing that you can all help. One second. One thing that
hmm,
you can all help me with, guys, is this. There is a little survey that is there on your Luma and Meetup. Whether or not you come to the boot camp is separate, but please fill the survey. It will ask you for your name and your phone number and your email address. You don't want to reveal it, put any name you want. Don't have to put the phone number. But one thing that if you fill helps me. If you give your technical background, then I understand the technical demographics of the audience. That helps me modulate the next time I give this talk. If it is a highly technical audience, then I've wasted your time with fluff. If it is an audience that is not used to AI, then perhaps this talk was more useful. In the former case, I can, next time I give the talk, I can make it more technical and deeper on that front. If on the other hand, the audience is looking for an invitation to AI, right, and to agents, then I need to perhaps soften it a little bit more and remove some of the the rare deeper technical stuff that I mentioned. So it helps me, guys. Please fill up that form. And with that, yeah, go ahead, Punendra. You want to say something?
yeah, there is a question in chat. Isn't this solution kind of a static or automated workflow? Just trying to understand the agentic part in this solution.
Yes. So this is a very absolutely correct. You got us there. This one actually is a static workflow. The agentic thing here is the agents independently reasoning over the text and coming to their decisions, to their assessments, without being told very specifically this or that. So it is an agentic system, and the first few agentic systems that you will build will be like will be quite close to static workflows, which is why a lot of people have this suspicion that workflows have gotten a new fancy name called AI agents. It's not that, but see, walk, crawl, run. Right? That's a basic thing. We need to do simple things before we can do more complicated things. So this code walkthrough that we have kept, we were fighting between two opposite objectives to create something that is of actual utility. So you see the value of AI agents, but at the same time is as simple as possible. So this was a Pareto optimization between the opposite objectives. All right, guys, if you don't have any other questions, we'll end today. And I'll be sitting here if anyone wants to informally come and talk. You're most welcome.